You think you know winter. Snow, cold, wind. But winter has weapons most people never see coming. Blizzards that erase the world in seconds. Ice storms that coat power lines until transmission towers collapse like dominoes. Ground blizzards that kill without dropping a single flake. Lake effect bands that dump 6 feet in 24 hours. Coastal bomb cyclones with hurricane force winds. Antarctic katabatic winds hitting 168 miles per hour. Each one is different. Each one kills. Which ones sit in weather records, and which ones are coming for your street. 3 key ingredients build a blizzard, and the National Weather Service defines them precisely. Sustained winds or frequent gusts exceeding 35 miles per hour, visibility reduced to 1/4 mile or less from falling or blowing snow, duration of at least 3 hours. Not the amount of snow. The wind. Environment. Canada requires 40 kilometers per hour for 4 hours or 6 hours north of the Arctic tree line. The official definition came together by 1859 in the western United States, but the term blizzard first appeared in 1829, meaning violent blow. The American Meteorological Society updated their glossary on March 26, 2024, confirming these criteria remain standard. Miss any one ingredient, and it is just a snowstorm. Hit all 3 and you have created a meteorological weapon. If you value documented atmospheric science and extreme weather history like this, subscribe. It is the best way to support our work. Also comment from which city you are hearing this from. This script is researched and factual using sources from the National Weather Service Storm Prediction Center updated November 2025, and the American Meteorological Society Glossary of Meteorology revised March 2024. These are peer-reviewed authoritative meteorological databases, not secondary summaries. Now back to the information. The pressure gradient between the low and a high pressure area to the west tightens. Wind accelerates. If snow is falling, the wind picks it up. If snow already covers the ground, the wind lifts it. Either way, visibility collapses. The wind chill plummets. In the Midwest, wind chills below negative 60 degrees Fahrenheit are routine during blizzard conditions. Temperature alone does not define a blizzard, but severe blizzards. Historically included temperatures of negative 12 Celsius or 10 Fahrenheit or lower. The colder the air, the drier, and more powdery the snow. Powdery snow blows easier, whiteout conditions develop faster. A person can become disoriented 3 meters from their door. Motorists must stop because the road vanishes. The phenomenon occurs through multiple mechanisms. Extremely heavy snowfall rates of 3 to 5 centimeters per hour or more. Diffuse lighting from overcast clouds, mist or fog. Snow already covering the ground. Wind-blown snow reducing visibility to near zero. In true whiteout, you cannot distinguish shadows, landmarks, or horizon. Aircraft in whiteout phase-controlled crash is the only landing option. The loss of depth perception causes spatial disorientation. People lose kinesthesia, which is the ability to sense body position relative to surroundings. The New England and mid-Atlantic coast get hammered by nor'easters, which are ocean-bred extratropical cyclones. Nor'easters form within 160 kilometers of shore between North Carolina and Massachusetts. They intensify as they track northward. Maximum intensity occurs near New England and the maritime provinces of Canada. The name comes from winds over coastal areas blowing from the northeast. Nor'easters bring heavy precipitation, strong winds, severe coastal flooding, and blizzard conditions. They develop most powerfully between November and March, when cold Canadian air meets warm Gulf Stream water. The Gulf Stream current runs near 21 Celsius, even midwinter. A bomb cyclone occurs when central pressure drops at least 24 millibars in 24 hours. The January 2018 nor'easter dropped 53 millibars in 21 hours, more than twice the bomb threshold. In Massachusetts, wind gusts hit 122 kilometers per hour on Nantucket Island. 17 inches of snow fell on Boston. A freezing storm tide of 4.62 meters flooded the financial district, including a subway station. New historical record. The October 20th 19 bomb cyclone over New England dropped more than 30 millibars in less than 24 hours. Nearly 500,000 people in Massachusetts and Maine lost power. The storm set low pressure records for October in Boston Providence and Portland, Maine. A study published in Proceedings of the National Academy of Sciences in July 2025 analyzed nor'easter data from 1940 to present using the ERA5 Global Reanalysis dataset. Researchers found the strongest nor'easters are becoming stronger. Maximum wind speeds of the most intense nor'easters above the 66th percentile are increasing. Hourly precipitation rates are rising. This suggests additional contribution to coastal risk in a warming world. The prospect of stronger nor'easters may bring increased winter cold, air outbreaks in neighboring regions due to increased cold advection on the westward flank of intensified coastal cyclones. The potential for future super nor'easters, driven by intense convection and explosive cyclogenesis, portends paralyzing snowfalls, dangerous storm surges, and episodic cold extremes. On December 3rd, 2025, a rapidly intensifying nor'easter brought 10 to 15 inches of snow, violent winds, and whiteout conditions across the Northeast. The central pressure fell from 1,002 mbar to 983 mbar in 12 to 15 hours, faster than bomb criteria require. Wind gusts reached 80 to 90 miles per hour, blasting Newfoundland during intense snowfall. The wind field was enormous, strong to severe winds spread across a large region. 2 to 3 feet of snow fell where heavy bands maximized. Combined with violent winds, impassable snowdrifts formed. This happened 2 days ago. The pattern continues. Winds increased to 50 to 60 mile per hour gusts. If several inches of fresh snow cover the ground, the wind creates whiteout instantly. The children's blizzard of 1888 killed an estimated 235 people in the Great Plains. The National Weather Service categorizes it as a ground blizzard. It was preceded by unseasonably warm weather. People ventured outside without proper winter clothing. The warm weather did not last. Temperatures plummeted. Winds roared. Visibility disappeared. Children walking home from school froze to death within sight of their homes. The iconic snowdrifts resulted from snow already on the ground and on frozen Lake Erie blowing across western New York. The lake froze early in December. Snowfall totals in December and January were unusually high. When high winds arrived, all that snow created drifts as high as second-story windows and power lines. The blizzard of 22 in December 2022 killed at least 38 people in western New York, surpassing the 77 death toll. 28 deaths occurred within Buffalo. Erie County Executive Mark Poloncarz called it the worst storm Buffalo has ever seen. Narrow bands form. These bands produce snowfall rates of 2 to 3 inches per hour or more. The bands are highly localized. One area gets buried while locations a few miles away see nothing. Syracuse, New York, directly south of Tug Hill Plateau, receives significant lake effect from Lake Ontario. Average snowfall is 115.6 inches per year, one of the snowiest large cities in America. Buffalo experiences lake effect from Lake Erie. Once Erie freezes, the lake effect stops. Erie is not as deep as the other Great Lakes, so it warms rapidly in spring and summer and frequently freezes in winter. Parts of Erie County, including Buffalo, received over 7 feet of snow. In some areas, snow accumulated at rates of 3 to 6 inches per hour. Winds between 30 and 50 miles per hour created near blizzard conditions. The storm exceeded forecasts. Roof collapses, structural failures, power outages, travel bans declared. Dozens of flights canceled or rerouted. Major roadways shut down, including Interstate 190, Interstate 290, New York 400, and a 132-mile section of the Thruway. Thousands of motorists stranded. Snowplows diverted from around the state. 11 deaths directly or indirectly caused by the storms. Over $46 million in damages. It is projected that warmer water and decreased ice cover will increase lake effect frequency and intensity. The October 12 to 13, 2006 lake effect event was the earliest in the 13-year archive by 2 weeks. Almost 1 million Niagara Frontier residents lost power, some for a week. Tree damage was worst in memory. The event was not particularly well forecasted. Depth of cold air was almost unprecedented for so early in season. Lake Erie was 62 degrees, 3 degrees above normal for October 12th. The event began with lake effect rain Thursday morning. By 3 p.m., it changed to wet snow. Little accumulation until 8 to 9 p.m. Then reports of trees falling and power outages increased rapidly after 2 to 3 inches of very wet, heavy snow weighed down trees. Near constant thunder and lightning for 12 hours. Cloud tops reached 25 to 30,000 feet, about double previously observed. This was attributed to phenomenal uplift over the 62-degree lake. 22.6 inches recorded at Buffalo Airport blew away any October record. Previous record was 6 inches in 1909. The November 2022 Great Lakes winter storm, nicknamed Snowvember 2.0, caused 2 deaths. Winter weather alerts affected over 8 million people in Great Lakes region. Travel bans throughout the weekend. Over 300 citations issued to drivers who violated bans. Dozens of flights canceled. Parts of Buffalo received over 6 feet of snow. Amherst got 18.7 inches. Sanborn 20.1 inches. Cheektowaga 23.6 inches. Understanding this mesoscale phenomenon is crucial for planning response and recovery for future devastating winter storms. Snowfall totals exceed 3 feet downwind of Lake Erie in northwestern Pennsylvania, Erie County in western New York, south of Buffalo, downwind of Lake Ontario in northern New York, an additional 1 to 2 feet possible before the storm winds down, snow falling between 1 and 4 inches per hour. Accumulations overwhelmed road clearing efforts, thundersnow and waterspouts reported. The area from Ashtabula, Ohio, through Erie, Pennsylvania, into Mayville, New York, hit hardest. Storm total snowfall may reach 3 to 4 feet from Chautauqua County shoreline through southern Erie County, Pennsylvania. In Michigan, Sault Ste. Marie reported 26.2 inches. Gaylord reported 33.8 inches. The 24.8 inches that fell in Gaylord on November 29th alone made it the city's snowiest calendar day on record. This is happening right now. An ice storm results from accumulation of at least 0.25 inches of ice on exposed surfaces from freezing rain. The United States National Weather Service uses this threshold. Freezing rain is liquid precipitation that freezes on contact with surfaces. The process requires specific atmospheric layering. Snow forms in clouds. The snow falls through a layer of above freezing air deep enough to completely melt the snowflakes into rain. The rain continues falling. It passes through a thin layer of sub-freezing air just above the surface. The layer is too thin for the drops to freeze before reaching ground. The drops become supercooled, temperature below freezing but still liquid. When supercooled drops strike anything below 0 Celsius, they instantly freeze, forming a film of ice called glaze. If the sub-freezing layer near the surface is sufficiently deep, the raindrops have time to freeze into ice pellets before reaching ground. That is sleet. Sleet bounces on impact. Freezing rain does not bounce. It conforms to the shape of whatever it hits. Roads, trees, power lines, utility poles, aircraft, buildings. The resulting glaze ice can accumulate to a thickness of several centimeters. The ice covers all exposed surfaces. Trees cannot support the weight. Branches snap, tree trunks split. Power lines coated with ice become extremely heavy. Support poles, insulators, and lines break. The ice on roadways provides almost no traction. Vehicles slide even on gentle slopes. Walking becomes extremely dangerous. Bridges and overpasses freeze before other surfaces. Eastern Ontario, southwestern Quebec, southern New Brunswick and Nova Scotia, northern New York, Maine, New Hampshire, Vermont. The storm lasted 6 days. The affected regions received 80 millimeters or more of freezing rain, double the amount of precipitation normally received in an entire year. At least 35 Canadians died. Causes included carbon monoxide poisoning, trauma fire, and hypothermia. 3 died weeks later clearing snow and ice from roofs. 945 injured, 600,000 people temporarily displaced. Nearly 1.4 million customers in Quebec lost electricity. Over 230,000 in eastern Ontario. Some areas without power for an entire month. 8 deaths in Maine, deadliest natural disaster in Maine history. More than 1,000 steel electrical pylons collapsed in chain reactions. 130 were major structures worth $100,000 each. Over 35,000 wooden utility poles pulled down. With many roads impassable due to fallen trees, broken power lines, and ice-coating emergency vehicles could barely move. The bridges and tunnels linking Montreal with South Shore closed due to weight concerns or ice chunks falling from superstructures. All but one power linkage to Montreal Island down for several days. Both city water pumping stations disabled. The Canadian Forces launched Operation Recuperation. Over 15,000 personnel deployed. Largest operational deployment since Korean War. Biggest peacetime deployment ever. 12,000 to Quebec, 4,000 to Ontario. Troops helped restore damaged electrical towers, freed power lines trapped in centimeters of ice, cleared roads down to trees debris, provided shelter food medical care. No water or ventilation for livestock. Many animals died. Barns collapsed under ice weight, killing animals trapped inside. Millions of trees brought down. Quebec's maple syrup industry was devastated. More than 1/5 of Canada's syrup-producing tree taps severely impacted. Countless branches and pipes collapsed. Some producers lost entire sugar bush. Industry losses in income likely tens of millions for 1998 alone. Damage so extensive many estimated years or decades for full recovery. The total financial cost estimated at 5.4 billion Canadian dollars. Figures vary by methodology. 1 to 3 billion in economic activity loss, 600,000 insurance claims totaling over 1 billion. 1 billion spent on hydro infrastructure repairs. 1 billion on provincial government costs, millions in federal government and military expense. 700,000 of Maine's 1.2 million residents without electricity. Maine National Guard mobilized. Utility crews from North Carolina arrived. 3 weeks after the storm ended, thousands still without electricity. In Quebec alone, 150,000 people without electricity as of January 28th. Prior to 1998, the last major ice storm to hit Montreal in 1961 deposited 30 to 60 millimeters of ice. The 1998 storm left deposits twice as thick. The storm resulted from a unique combination of weather systems. An upper-level low stalled over Great Lakes. It pumped warm, moist air from Gulf of Mexico toward upper St. Lawrence Valley. Upper flow turned eastward, bringing this air mass toward Bay of Fundy. A high-pressure center sat in Labrador, keeping easterly flow of very cold air near surface. An unusually strong Bermuda high anchored over Atlantic prevented systems from moving east, as most winter storms do. The collision zone between warm air aloft and cold air at surface created perfect conditions for prolonged freezing rain. The narrow band ahead of a warm front associated with a mid-latitude cyclone is typically less than 50 kilometers wide. When wrapped around and behind the low-pressure center by counterclockwise winds, this narrow band produces the most devastating ice storms. Cedar Rapids Airport recorded 0.68 inches. Multiple locations recorded 0.4 to 0.5 inches. This recent event demonstrates ice storms continue to threaten infrastructure and safety. The severity depends on accumulation amount, duration, wind speed during accumulation, whether urban or rural area. Urban areas suffer more economic and physical damage due to a concentration of utilities and transportation systems. A quarter inch of ice glazes roads, impacts travel, results in some tree damage, causes power outages. When ice accumulates to 1/2 inch or more major and crippling effects occur. Strong winds during ice storms greatly compound damage by causing added stress to trees and power lines already laden with ice. Unlike snowstorms where snow can be plowed in hours or a day, damaging effects of ice storms can last days or weeks. Occur 0 to 2 times per generation in any spot. That often means not planned for since they have not happened in residents' memories. Extended widespread power outages lasting several days. Power outages knock out heat to homes causing hypothermia threat. Loss of electricity indirectly leads to death. Ruptured pipes from water freezing inside. Communication cut as ice downs phone lines, damages cell towers. Freezing rain of any amount is dangerous. Small amount on roads, parking lots, sidewalks creates slip and fall dangers. Icy roads with many more accidents. Ice storm warnings should be taken seriously. Freezing rain. Advisories garner substantial action. Mountains receive much precipitation as snow given colder temperatures at altitude. Combination of boosted winds and heavy snowfall makes mountain blizzards commonplace. In Pacific Northwest, winter storms spread as extratropical cyclones march in one after another. Mild, low elevations see gusty rains. High country of coast mountains, Olympic Mountains, Cascade Range, endure days of blizzard or near blizzard conditions. These are some of snowiest mountain masses on Earth. Mountain blizzards, though localized, can be just as deadly as widespread plains blizzards. Avalanche risk increases. Rescue operations become impossible. Ski areas close, mountain passes shut down. Commonwealth Bay in Antarctica is listed by Guinness World Records and National Geographic as windiest place on Earth. Winds regularly exceed 240 kilometers per hour. Average annual wind speed is 80 kilometers per hour. That average exceeds threshold for gale force. Storms caused by katabatic winds. Katabatic means downslope flow of dense, cold air under gravity. The Antarctic ice sheet produces extremely cold, dense air. This air flows downhill from high polar plateau toward lower coast. As it descends, the gradient steepens, wind accelerates. Where winds concentrate into restricted coastal valleys, they blow well over hurricane force, reaching 160 kilometers per hour to 300 kilometers per hour. He established main base at Cape Denison in Commonwealth Bay. In The Home of the Blizzard, published 1915, Mawson described experiencing estimated instantaneous wind speeds exceeding 75 meters per second. That is 270 kilometers per hour, or 168 miles per hour. On March 24, 1912, Mawson recorded hourly wind speed of 48.9 meters per second, 176 kilometers per hour, or 109 miles per hour. Later studies adjusted this to 41.6 meters per second, 149 kilometers per hour, or 93 miles per hour. High wind speed sensors deployed at Cape Denison in 1995 measured 10-minute average gusts exceeding 57 meters per second, 205 kilometers per hour. Mawson wrote for 9 months of year in almost continuous blizzard rages, and for weeks one can only crawl about outside, unable to see an arm's length owing to blinding snowdrift. At Mawson Research Station on East Antarctica coast, where ice cap falls steeply to sea, gravity-fed katabatic winds roar down slope. In recent years, 19 Australians endured epic 7-day blizzard. Wind blew between 100 to 148 kilometers per hour. One gust reached 244 kilometers per hour. Visibility 0 for days. Force of winds moved fully laden shipping containers. Team followed rope or blizz line to move between buildings. Moving even small distance in Antarctic storms, is feat of strength and endurance. The highest recorded wind velocity in Antarctica is 199 miles per hour, or 327 kilometers per hour at Dumont d'Urville in July 1972. Comparable to strongest wind gust recorded on Earth, surface of 231 miles per hour, or 371 kilometers per hour at Mount Washington, New Hampshire, on April 12, 1934. This desiccates the region. The force of winds mobilizes sand and small rocks, shaping exposed rocks into fantastic shapes called ventifacts. Wind is most important factor in Antarctic weather. It can be pleasant at negative 40 degrees in sunny, calm weather. Barely freezing conditions are hell when wind blows hard. Paul Sipple, Antarctic explorer and Boy Scout, coined term wind chill in 1939, defined time to freeze cylinder of water. Found wind speed was important factor. Wind chill formula. Weather Service uses now is different, but idea same. Freezing effect of wind worst when skin directly exposed. That why Weather Service uses exposed skin as basis for determining apparent wind chill temperature. When conditions are classified as blizzard with gale force winds for at least 1 hour, temperature less than 0 Celsius visibility reduced to 100 meters. Or less, conditions are dangerous and disruptive. Sometimes blizzards last days. The White Hurricane of 1913 was deadliest and most destructive natural disaster to hit Great Lakes Basin. It produced 90-mile-per-hour wind gusts, waves over 35 feet high, whiteout snow squalls, killed more than 250 people, destroyed 19 ships, stranded 19 others. The Armistice Day blizzard of November 10th to 12th, 1940, took place in Midwest on Armistice Day. This panhandle hook winter storm cut 1,600-kilometer wide path through middle of country from Kansas to Michigan. Morning of storm was unseasonably warm. By mid-afternoon, conditions quickly deteriorated into raging blizzard lasting into next day. Total of 145 deaths blamed on storm. Almost a third were duck hunters who had taken time off. The massive explosion of volcano Krakatoa in South Pacific in August 1883 is suspected cause of huge blizzards during several years following. Clouds of ash circulated around world for many years. Weather patterns remained chaotic. Temperatures did not return to normal until 1888. Krakatoa eruption injected unusually large amount of sulfur dioxide high into stratosphere reflecting sunlight, helping cool planet until suspended atmospheric sulfur fell to ground. Plains blizzard of late 1885 saw heavy snows pile drifts 10 feet high in Kansas. Kansas blizzard of 1886, first week of January, reported 80% of cattle frozen to death in state from cold and snow. The Veterans Day storm of November 9th to 14th, 1996, saw over 160,000 customers without power in greater Cleveland alone. Storm produced isolated snowfall approaching 70 inches. These historical events demonstrate blizzards have killed consistently across decades. Each generation faces storms exceeding anything in living memory. Then winds increase, creating ground blizzard from existing snow. Lake effect bands add localized extreme accumulation. Then, nor'easter intensifies offshore, pulling Arctic air south. Ice storm follows as warm layer aloft overruns surface cold. Power fails, roads close. Emergency services cannot respond. Hypothermia sets in, carbon monoxide poisoning from improper heating, structural collapse from ice and snow weight. This cascade of winter hazards explains why modern forecasting remains crucial despite satellites, computer models' hourly data. Small changes in atmospheric temperature profile through first few thousand feet make massive difference between rain, freezing rain, sleet, or snow, ice storms notoriously hard to forecast. A 2024 study by Coburn, Bartholome, and Pryor, published in Environmental Research Letters titled Quantifying the Compound Hazard of Freezing Rain and Wind Gusts Across CONUS, examined the combined threat. Freezing rain and wind gusts together create compound hazard worse than either alone. The research found these compound conditions occurring with increasing frequency. The prospect of stronger nor'easters combined with ice accumulation and high winds represents severe future threat to coastal and inland communities. The February 1994 ice storm resulted in tremendous ice accumulation as far south as Mississippi, caused reported damage in 9 states. While meteorologists can predict broad patterns, the exact track of heaviest precipitation remains challenging. For blizzards, verifying conditions with automated weather stations is difficult. Stations may struggle observing low horizontal visibility, may have urban sheltering from blowing snow. Criterion requires at least 3 consecutive hours, with winds at least 35 miles per hour, and visibility at or below quarter mile. Frequent means something specific, but observation methods vary. Achieving those sustained conditions over required duration depends on exact storm track and intensity. High tide timing, critical for ice storm severity since ice accumulation combined with tides causes storm surges flooding coastal cities. The January 2022 nor'easter threatened 75 million people from southeast to New England with snow, wind, and flooding. Blizzard warnings expanded to cover 10 million people across 10 states from New England to Virginia, including Portland, Maine, Boston, Cape Cod, eastern Long Island, Atlantic City, New Jersey, Ocean City, Maryland. Eastern Massachusetts, including Boston, could see 18 to 24 inches of snow combined with wind gusts to 70 miles per hour. 2 to 4 inches per hour snowfall rates. Conditions peak between 8 a.m. and 5 p.m. New York City could get 8 to 12 inches with 45 mile per hour gusts. 14 inches possible elsewhere in New York State and Connecticut with wind gusts to 55 miles per hour. Piling up to 30 inches some spots. If band reaches Boston City, could near its one-day snowfall record of 23.6 inches set February 17, 2003. Heaviest snowfall likely to fall across swath from eastern shore of Maryland through most of Maine. 6 to 12 inches are likely. Parts of coastal New England with blizzard conditions may see 1 to 2 feet with locally higher amounts over coastal Massachusetts. American Airlines and JetBlue grounded planes, travel ground to halt. The combination of strong northeast winds and high seas brings storm surges that, with high tide, lead to minor or moderate coastal flooding. National Weather Service said, Friday evening there is high confidence this will be a historic major winter storm for eastern New England. The social and economic impacts extend beyond immediate danger. Schools closed for weeks, supply chains disrupted, grocery stores empty, fuel deliveries delayed, elderly populations isolated, medical emergencies cannot reach hospitals, dialysis patients miss treatments, insulin supply interrupted. Emergency generators run out of fuel, shelter capacity overwhelmed, mental health crisis from isolation, financial hardship from missed work, small businesses fail, insurance claims bankrupt companies. The 1998 ice storm economic impact exceeded $6 billion United States dollars when combining all affected areas. That is 30 years ago. Adjusted for inflation and increased infrastructure density, modern equivalent ice storm would cause tens of billions in damage. Understanding these storm types matters because preparation differs. For standard blizzards, stock food, water, medications, fuel for several days, secure outdoor items, avoid travel, stay indoors during peak. For ice storms, the priority shifts. Assume power outage lasting days or weeks. Have alternative heat source with proper ventilation, carbon monoxide detector essential, generator outside only. Never run vehicles or generators indoors. Stock non-perishable food requiring no cooking, battery-powered or hand crank radio, flashlights batteries, first aid supplies. Medications for at least 2 weeks. For lake effect snow, if you live in snowbelt, keep vehicle stocked with blankets, food, water. Snowfall can intensify from nothing to 4 inches per hour in minutes. A 10-mile drive becomes overnight ordeal. For nor'easters, along coast elevation matters. Storm surge flooding risk increases at high tide. No evacuation routes. Coastal communities need vertical evacuation plans. For Antarctic conditions, well, nobody lives there voluntarily for good reason. Research stations maintain blizz lines between buildings, stock supplies for year. Have redundant systems for everything. When cold air masses do arrive, they can tap that increased moisture producing heavier snowfall. Lake effect snow depends on temperature difference between lake surface and air above. Warmer lakes increase that difference until lakes freeze. Once Great Lakes freeze, lake effect stops. But warmer winters mean lakes freeze later or not at all, extending lake effect season. The nor'easter research shows strongest storms intensifying. Ice storms may increase in frequency as temperature profiles allow more warm air aloft over surface cold. The margin between rain and ice is narrow. Slight shifts create ice storm conditions over wider areas. Roads engineered for freeze-thaw cycles now see ice loads causing structural failure. Buildings rated for Y snow load now receive Y plus ground blizzard drifting, adding uneven dynamic loads. Roof collapses increase. Emergency response systems designed for Z number of simultaneous incidents now face Z times 3. The system fails. Cascade effects multiply. One failure causes 3 more. Redundancy proves insufficient. Infrastructure aged. More people dependent on electricity for medical equipment. Electric vehicles need charging, smart homes need power, remote work needs internet. The grid is more interconnected, creating vulnerability to cascading failure. The maple syrup industry never fully recovered from 1998. Some orchards still show damage. Some producers never rebuilt. Economic loss persists decades later. The 14-day lake effect event, November 2006, destroyed century-old trees in Buffalo's historic parkways and parks. The urban tree canopy still shows gaps. The ecological impact of extreme winter weather persists long after snow melts and ice thaws. In Greenland, katabatic winds called pittorak are most intense when low pressure approaches coast. In Antarctica, katabatic winds are dominant feature-shaping landscape. The McMurdo dry valleys are scoured clean by force of katabatic winds. No snow remains. Relative humidity so low the region is desiccated. Blue ice areas form where snow removed and surface ice sublimates, but is replenished by ice flow from interior. The Great Salt Lake in Utah causes lake effect year-round since lake never freezes. Lake effect contributes to 55 to 80 inches annual snowfall south and east of lake. Average snowfall in Wasatch Range reaches 500 inches or 13 meters. In northern Europe, cold, dry air from Russia blows over Baltic Sea, causing heavy snow squalls on southern and eastern coasts of Sweden, Bornholm Island, east coast of Jutland, northern coast of Poland, coastal Norway, from Kragerø to Kristiansand, have had incredible snow depths. City of Arendal recorded 280 centimeters or 110 inches in single week late February 2007. January 1987 saw record-breaking cold air move across North Sea toward UK. Result was over 2 feet of snow for coastal areas, communities cut off for over a week. Latest events to affect Britain's east coast occurred November 30th, 2017, February 28th, 2018, March 17th, 2018, in connection with 2018 Great Britain and Ireland cold wave. These global examples demonstrate katabatic and lake effect snow are not isolated to North America. The mechanisms are universal wherever temperature gradients exist between cold air and warmer water, or elevation differences allow dense cold air to flow downhill. The human stories within these statistics are what matter. The children's blizzard killed 235. Most were children walking home from school. Teachers tried to keep students inside, but some ventured out. Whiteout conditions, negative 40-degree temperatures. Children froze within meters of homes. Bodies found in spring thaw. The Armistice Day blizzard killed almost 50 duck hunters. Unseasonably warm morning. Hunters wore light clothing. By afternoon, Arctic front hit. Temperatures plummeted 30 degrees in hours. Winds reached 60 miles per hour. Hunters stranded in boats on Mississippi River froze to death. The 1998 ice storm elderly died from hypothermia in their homes. Carbon monoxide poisoning from bringing barbecues indoors for heat. 3 people died weeks later, clearing ice from roofs. Hearts gave out from exertion. The 2022 Buffalo blizzard, 28 deaths within city limits. People trapped in cars, went outside to clear tailpipes, collapsed from cold and exhaustion. Bodies found buried in snow days later. Blizzards kill through hypothermia, exposure, disorientation, vehicle accidents. Ice storms kill through carbon monoxide, poisoning, falls, power outage complications. Lake effect snow kills through vehicle accidents and roof collapses. Nor'easters kill through coastal flooding, storm surge, and blizzard conditions combined. Antarctic conditions kill anyone unprotected within minutes. The wind chill at negative 40 with 100 mile per hour, winds approaches negative 150 degrees. Exposed flesh freezes in under 1 minute. Breathing becomes difficult. Frostbite is instant. Core temperature drops. Confusion sets in. You sit down. You do not get up. The 2014 Buffalo Lake Effect event. November 17th to 19th produced snow at rates exceeding 6 inches per hour near tail end. Cloud tops reached 25 to 30,000 feet. Thunder and lightning constant for 12 hours. 11 deaths. 46 million in damages. This year just passed its 10-year anniversary. Everyone who lived through it remembers exactly where they were, how they got home, who they called, whether they had power, how long they were trapped, what they ate, how they stayed warm. These events scar community memory. They become reference points. Time splits into before the storm and after the storm. Every subsequent storm is compared to that storm. Is this worse than 14? Worse than 77? Worse than 98? Survivors carry trauma. First snow of season triggers anxiety. Weather forecasts create dread, perfectly rational fear based on experience. The study tracked blizzard occurrence from 1948 through 2000. Analysis revealed temporal and spatial variations in freezing rain. High-frequency areas identified in western Minnesota, western Iowa. Banned from central Illinois eastward through northern Indiana, Ohio, and eastward. In high-frequency band and Midwest, average of 12 to 15 hours of freezing rain occurs annually. Most events, December and January. While freezing rain can occur November through April, concentration in midwinter. Damage depends on accumulation, amount duration, wind speeds, storm timing, and affected area. Quarter-inch impacts travel. Half-inch or more creates major crippling effects. Strong winds during ice accumulation compound damage exponentially. The 1998 ice storm produced largest estimated insured loss in Canadian history at 1.44 billion Canadian dollars. Combined Canadian and United States insured loss exceeded 1.75 billion Canadian dollars. Individual claims numbered 600,000. Some homeowners filed multiple claims: contents damage, building damage, additional living expenses while displaced, tree removal, vehicle damage from falling ice and branches, business interruption claims. Municipalities filed claims for infrastructure damage. Utilities filed claims. Insurers paid, then went bankrupt. Reinsurers covered losses. Premiums increased region-wide. Some insurers stopped writing policies in affected areas. Risk became uninsurable. Property values declined. Economic recovery took years. Facts are documented. The National Weather Service definitions last updated 2024. The American Meteorological Society Glossary revised March 2024. The Proceedings of the National Academy of Sciences study published July 2025. Environment Canada official records. Statistics Canada Disaster Database. The Insurance Board of Canada claims data. University research from multiple institutions. Peer-reviewed journals. Government meteorological agencies. Historical expedition records from 1912. Recent weather events from November and December 2024. This is not speculation. This is measurement, observation, analysis, peer review, scientific consensus. Lake effect dumping 6 feet localized. Nor'easter with bomb cyclone explosive intensification. Ice storm coating everything in glaze. Mountain blizzard in channeled valleys. Antarctic katabatic hitting 168 miles per hour. Each has unique formation mechanism. Each has specific geographic occurrence pattern. Each has documented death toll. Each has measured parameters. Each sits in weather records, and some are happening right now. The nor'easter that hit 2 days ago, the lake effect pounding Great Lakes as of yesterday. These are not historical curiosities. These are current events. Because every winter these storms form. Every winter they intensify. Every winter they move toward population centers. Every winter emergency managers issue warnings. Every winter some people listen and some do not. Every winter the death toll adds up. Every winter the economic damage compounds. Every winter the historical record expands. 127 miles per hour. That is 10-minute average, not gust, sustained, for 10 minutes. At that speed you cannot stand, you cannot breathe, you cannot see, you cannot think. The only option is shelter. If you have no shelter, you die. Simple as that. The Antarctic teaches this lesson repeatedly. Mawson's expedition 1911 to 1914. Multiple deaths, some from scurvy, some from falls into crevasses, some from exposure. Every expedition since has had casualties. Modern equipment helps, but wind and cold and isolation kill regardless of technology. Expedition left a small party to overwinter and search for him. Mawson survived. Wrote The Home of the Blizzard. His account stands as primary source for katabatic wind conditions at Commonwealth Bay. The measurements may have been adjusted by later research, but the experience was real. Mawson did not exaggerate. If anything, he understated. Survivors of extreme events rarely convey full horror because language is inadequate. You had to be there. You had to feel that wind. You had to see that darkness. You had to know you might not survive. The same applies to blizzard survivors. You tell people about the children's blizzard, they nod. They think they understand, they do not. You tell people about the 1998 ice storm, they imagine a few hours without power. They do not grasp a month without electricity in January in Quebec. Negative 20 Celsius outside, no heat, no light, no way to cook, no way to communicate. Cut off, isolated. Hoping emergency services find you before you freeze. Hoping generator fuel arrives. Hoping power restoration happens before food spoils, before pipes burst, before you die. The historical record exists because we must learn from past to prepare for future. The research continues because storms evolve. The atmosphere changes. Climate shifts. What worked before may not work next time. What failed before will fail again unless corrected. As of December 1st, 2025, snowfall tops 6 feet in western New York, triggering road closures, flight cancellations the weekend before Thanksgiving. Paralyzing amounts of snow continue to smother towns. Record-breaking lake effect snowstorm blasts region, prompting major road closures, travel bans. Snowfall totals exceeded 3 feet downwind of Lake Erie in parts of northwestern Pennsylvania, Erie County, and western New York, south of Buffalo. Downwind of Lake Ontario in northern New York, additional 1 to 2 feet possible before storm winds down. With snow falling between 1 and 4 inches per hour, accumulations overwhelm efforts to keep roads clear under heaviest bans. This is not historical record. This is news from yesterday and today. The higher community survival odds, the lower death toll. The lower death toll, the less trauma. The less trauma, the stronger recovery. The stronger recovery, the more resilient system. The more resilient system, the better outcome next time. Commonwealth Bay average wind speed 80 kilometers per hour every year. Standard blizzards hit Great Plains and Midwest multiple times per winter. Lake effect snow falls every season on Buffalo, Syracuse, Erie. Nor'easters form every winter along coast. Ice storms strike eastern North America every few years. The frequency varies, the intensity varies, the location varies, but the occurrence is guaranteed. Not gusts, sustained, for half a day. Imagine standing in that, imagine trying to work in that, imagine trying to survive in that. Mawson and his men did, because they had no choice. They were stuck for a year. Ship could not return until next season. They either adapted or died. They adapted, barely. The lesson is adaptation. Learn the storm types, know your region's threats, understand formation mechanisms, follow forecasts, heed warnings, prepare appropriately, stock supplies, have backup plans, establish communication protocols, check on neighbors, help vulnerable populations, follow emergency manager guidance. Do not be the person who ignores blizzard warning and drives into whiteout. Do not be the family running generator indoors and dying from carbon monoxide. Do not be the homeowner who did not trim trees and loses power when ice-laden branches snap. Do not be the statistic. Their communities remember. The records preserve memory. The research ensures we learn. The knowledge enables prevention. You can understand ice storms perfectly and still lose power if you do not prepare. You can memorize storm criteria and still get caught if you do not check forecast. Knowledge must translate to behavior. Behavior must translate to preparation. Preparation must translate to survival. So when National Weather Service issues blizzard warning, you do not go outside. When they issue ice storm warning, you assume power outage and prepare. When they issue lake effect snow warning in Buffalo, you do not travel. When they issue nor'easter forecast on coast, you check tide tables and elevation. When you see Antarctic Research Station weather report showing katabatic winds, you thank whatever forces keep you anywhere else. That is fine. The lesson travels. Extreme conditions exist. Respect them. The children's blizzard is not coming back, but ground blizzards still form. Different children, different schools, different decade, same mechanism, same danger. The 1998 ice storm was a unique combination of factors, but ice storms still happen. Different year, different location, different scale, same glaze, same weight, same collapse. The 2014 Buffalo lake effect was extraordinary, but lake effect continues. Different storm, different month, different totals, same bands, same rates, same burial. As long as pressure gradients exist, the storms will form, the blizzards will blow, the ice will accrete, the winds will howl, the visibility will collapse, the power will fail, the people will die. Unless they prepare, unless they adapt, unless they learn. The Cape Denison expedition left Maine Base in February 1914 after 2 years. They departed having documented the windiest place on Earth. They departed having survived conditions that killed lesser men. They departed having contributed measurements still referenced in 2025, over 100 years later. The automatic weather station installed in 1995 continues recording. The data flows to satellites. Satellites transmit to ground stations. Ground stations feed models. Models inform forecasts. Forecasts enable warnings. Warnings save lives. The katabatic wind research helps us understand how topography channels flow. That understanding improves mountain blizzard forecasts. The ice storm forensics from 1998 inform power grid engineering standards. Those standards reduce outage duration in future events. The lake effect observations from October 2006, earliest snow on record, improve early season forecasting. That improves early season preparation. Everything connects. Every measurement contributes. Every storm teaches. Every death instructs if we let it. In 1995, Cape Denison high wind sensors measured conditions Mawson estimated in 1912. Technology caught up to observation. The numbers aligned. Mawson was right. The winds really do exceed 160 kilometers per hour. Really do sustain for hours. Really do create conditions incompatible with human life unprotected. The validation matters because credibility matters. When scientist says storm will be historic, believe them. When emergency manager says do not travel, listen. When meteorologist says life-threatening conditions are expected, they mean it. These are not people prone to exaggeration. These are people trained in measurement and understatement. When they use superlatives, pay attention. When they say unprecedented, take seriously. When they compare current event to historical worst case, prepare for worst case. The lake effect event right now burying Pennsylvania and New York under 3 to 4 feet. That accumulation rate, that duration, that spatial concentration, extreme. These assessments come from National Weather Service forecasters who have seen thousands of storms. When they call it historic or extreme, the adjectives are earned. Then comes the winter that fails, the storm that exceeds design, the cold that breaks records, the snow that buries, the ice that collapses, the wind that destroys. That winter defines the next decade. Buildings are rebuilt to higher standards. Codes are updated, equipment is upgraded. Budgets are increased, attention is paid, until memory fades, until complacency returns, until next storm exceeds new standards and cycle repeats. Requires learning from near misses, not just from catastrophes. Requires regional cooperation because storms do not respect borders. Requires technological advancement because forecasting improves survival. Requires public education because informed citizens make better decisions. Requires political will because preparedness costs money. Requires cultural shift from reaction to prevention. Requires everything we have. The ice storm frequency models show that. The climate data show that. More moisture in atmosphere, higher ocean temperatures, less Arctic sea ice, slower jet stream, more meridional flow, greater temperature gradients, all combine to create conditions favoring extreme events. Not more frequent necessarily, but more intense when they occur. Not every winter, but big winters bigger. Not every storm, but big storms breaking records. The answer requires atmospheric physics and historical documentation and statistical analysis and case studies and mechanisms and measurements. But the answer boils down to simple truth. Winter has weapons. They have names. Standard blizzard, ground blizzard, lake effect snow, nor'easter, bomb cyclone, ice storm, mountain blizzard, Antarctic katabatic. Each kills, each is documented, each is measured, each is forecast, each is understood. Understanding creates opportunity for survival. Survival depends on preparation. Preparation depends on knowledge. Knowledge depends on research. Research depends on observation. Observation depends on being willing to measure conditions at Cape Denison at Commonwealth Bay, where the winds hit 168 miles per hour and staying alive long enough to write it down so that generations later, someone in Buffalo or Quebec or Erie can read the warning and make the choice to survive.